All right, let's take a look at these problems, which came out looking like that. By the way, if you already wadded this up and thrown it away, that's what it looks like to me. But anyway, here's question number 1. Sandra and Jill both take their history test. And Sandra scores an 86. So let's indicate that. Sandra. And by the way, whatever score they got, that's called the raw score. And Jill scores a 94. All right, and it asks, using the information given below, determine how many more students did Jill beat with her score than Sandra did. And what you have to realize is, and basically I'm looking at pages 46 and 47 of your text. I'm given some information here. The mean, that is the average score, is 82. And S, the standard deviation, is 5. And I'm told that the number of students that took the test is 62. And here's what you got to realize. You've got a bell-shaped curve. This is a normal distribution. So it basically goes like that. And this is just an estimate. But you know that with a normal bell-shaped curve, the very center point is the mean, which is 82. So 82, these are the frequencies, these are the scores right here. Now, the standard deviation is 5. And one thing that, let me find the page in your textbook that illustrates this. And it's page 46, shows you that one standard deviation on each side of the mean, and the standard deviation is 5, so that's 5 above up to 87, and 5 below, that's down to 77. So between one standard deviation below and above the mean, this is 68% of all the grades. This is the majority of the grades right here. Hey, another standard deviation, 5 more, that'll take us to 92, take us down to 72. I'm told that this is 95% of all the grades. And then a third standard deviation, that'd be up to 97. This is down to 67. Between 3 standard deviations below and 3 standard deviations above, this will make up like 90, almost all of 99%. Just a rare occurrence. Something will come below 67 or above 97. So again, 68% in here, 95% within 2 standard deviations, 99% within 3 standard deviations. Well, okay, let's see. Sandra got an 86. Here's an 86 right here. So here's Sandra's score. This is Sandra. And Jill, she knocked it out of the park. She got a 94. Now, obviously, Jill did a lot better than most of the students. Sandra did better than most of the students, but Jill did a little bit more than Sandra. So what we're going to find out is how many students out of the 62 did Sandra beat. In other words, how many are below Sandra's grade of 86, and how many are below Jill's grade of 94. And then we're going to compare the two and see how many more Jill beat than Sandra. So what we're going to use is what you see on page 47, what's called the Z-score or the standard score. And it gives you the formula there. Basically, it's the raw score minus the mean all over the standard deviation. This is your important fraction formula for these problems. All right. So first of all, let's do Sandra. For Sandra, Sandra's standard score, or her Z-score. Okay, so it's going to be her raw score, 86. Raw score is just what you got, minus the mean, which I'm told is 82, all over the standard deviation, which is given to be 5. So 6 minus 2 is 4 over 5, so I get 0.80. Now her Z-score is 0.80. This doesn't tell me anything until I know that there is a chart, a normal curve table, Appendix B at the back of your textbook. Goes from negative 2.99 to positive 2.99 in increments of 1/100th. So I go until I find 0.80. Here it is, 0.80 is my Z. See, my Z for Sandra is 0.80. Now I want to know what percentage of the people she did better than. So I want to know what's below this particular amount. So I got a 0.80, and then I look at proportion below. And below is 78, or a 0.7881 it says. This is the amount below, 7881, and the amount above is 0.2119. These should, by the way, both add up to 1, the whole thing. So the amount below is 0.7881. I'm going to write that down. So the amount below is 0.7881, but I'm going to express this as percentage, which means I move the decimal 2 places. 78.81, or approximately 78.8%. So I know that Sandra did better than 78.8% of the people in this particular testing. Well, how many people took the test? 62. So what I'm going to do, and here I sit without a calculator, what I'm going to do is multiply the number of students by 78.8%. So it's going to be 62 times 78.8%. All right, I just realized something here. This is obviously going to give me a lot more than 62 people. So what I'm going to multiply by is not the percentage, but the decimal. And I might as well leave it 0.7881. It is 78.8%, but getting the accurate number, I'm going to multiply by the decimal. So I'm going to multiply 62. Like I said, I don't have my calculator with me. Let's see what I can do here. Okay. 0.7881 times 62 gives me 48.8622. Now here's a question: if she did better than 48.8 people, how many did she do better than? If I'm thinking 0.8 of a person doesn't count as a whole person, I'm thinking she did better than 48 people. Because that 0.8 doesn't get me up to 9. This is where I don't know if they have particular ways of rounding, but she did better than 48 people. That's Sandra. Let's do Jill. Jill's z-score is going to be her raw score, which is 94, minus the mean, which is 82, all over the standard deviation, which is 5. So that's 12 over 5. That's 2.4. So her z-score is 2.4. And it only goes up to 3, so she did really, really well on the test. So 2.4 is what I look for in my chart. 2.40 right there. The amount below is 0.9918. Amount below, .9918. So I'm going to multiply 62 times 0.9918 to find out how many people are below Jill. So here we go. 0.9918 times 62 is 61.4, which means she did better than 61 people. So Sandra did better than 48 people. Jill did better than 61 people. The question is, how many more people did Jill whoop than Sandra? And so all I gotta do is subtract 61 minus 48. And the answer to this particular question is 13. So all these problems work basically the same way. You're going to have a different mean, a different standard deviation, a different number of students, but you're always going to use this to find your z-score. You're going to go in the back of your book to Appendix B, look up your z-score, and remember, the question is, are you looking for how many are below your grade or how many are above your grade? So it's going to be one of these two numbers. So all right, I'll pause it right there.